Okay, welcome to the video lecture series on C programming. So today we will try to see problem solving techniques. So first one we have a algorithmic approach. Algorithmic approach is the most systematic and logical, widely used problem solving technique. So we already seen in last lecture series the definition of algorithm. Once again we will see algorithm is nothing but a sequence of clear and step-by-step instruction. If you follow the step-by-step instruction, so we can easily solve our problem. Okay, if you have any problem, so if you follow the step-by-step procedure, you can see example we have here. So algorithm is simply a step-by-step process. If you follow the step-by-step process clearly, and then we will obtain the solution for any type of problem. So you can see here we have an algorithm where starting we have an algorithm start, then we'll be reading three numbers. So each and every step says clearly, so they are saying unambiguous statement. So each and every steps they are saying clearly what they are intended to. So first step is start. That means we are starting our program or algorithm next. So that is the start of problem. Then we will read three numbers. That means we are taking input for our uh, algorithm. Then we are calculating, that is a plus b plus c, and finally we will be calculating the final output, that is average, which is sum by 3. So and after calculating average, our intention is to display our average. So we are displaying it here. So this is our intention. So this is displaying average is our intention. So definitely we displayed here, and our problem was solved. So this is our problem to display average of three numbers. So our problem was solved. Finally we'll be going to stop here. So this is called algorithm approach. You see so there are key idea of the algorithmic approach. So there are very key points are there. First one, so we are breaking the problem into small subparts, and we are solving those subparts individually. Okay, so that is manageable. So we'll be have a large problem. This large problem was divided into sub problem. Okay, this large problem was divided into sub problem. So we'll be solving this sub problem individually. Okay, then we'll be combining such a that we will be obtaining a final solution, or final problem solution will be obtaining. So that is the breaking down the problem into small and manageable and ambiguous statements. Then so each step should be algorithm, we already seen each step will define exactly what they are intended to. Okay, then so when you written any algorithm, it guarantees that it will gives you output. Okay, any algorithm, so it will results an output, and whatever step is there, each algorithm step will end in a finite time. Okay, in finite time of interval, that is in a particular interval, definitely the step should be completed. Okay, if it is not completed, if it is not completed means it will go to infinite. So it will never ending process. That means each and every step should be completed within a stipulated time. Okay, so that is the key idea of the algorithmic approach. Next, we have a characteristics of algorithmic approach. So first one, we have a finiteness, then we have a definiteness, then we have a, it should have a input, and it should have a output, and it should be effectiveness. First we see finiteness. That means algorithm must and should contain a finite number of steps. If you see this example, in this example we have a 1 2 3 4 5 6. So algorithm is having 6 steps. Every algorithm must and should have a finite, that is a countable number of steps should be there. So then that is the character, that is the first characteristics of finiteness. And the second one, we have a definiteness. Definiteness means each and every step of the algorithm should precisely define. That means the each and every step should be clearly defines what it intended to do. That means what is doing. Suppose if we take an example here, this is suppose one step, a is equal to b plus c. That means it is clearly saying that they are adding two numbers, okay, a b plus c, and they are saving that result into a. So this is a one step of algorithm. It is clearly saying that what is it intended to do. Okay, then we have a input. So every algorithm must and should have a well defined input. Okay, so if it is so that is the input. You can see the input will be taken with the help of scanf function. Okay, then we have a output. So each every algorithm must and should have at least one well defined output. It definitely need to obtain a output. Without that algorithm is not a good algorithm. Then the last one, effectiveness. If you see effectiveness, I already said in previous slide, each and every step should be completed within a finite time. Okay, whatever step we seen in algorithm, so that means if I say start, it should take some t0 time to start. Okay, next one, read three numbers, it will take some t1 time. So it will have a finite time to complete. If I take calculate some, it will take some time. It will, the step should be completed in a finite, that means a countable time step it will complete. Okay, so here we have a five characteristics of good algorithm. First one, finiteness, definiteness, input, output, and effectiveness. Then so there are there are steps in algorithmic approach. So first one you see, understand the problem. Second one we have analyze the problem. Third one we have design of the algorithm. Fourth one we have implement the algorithm. Fifth one we have test and verify. And sixth one we have optimize and refine. And seventh one we have document and maintain. Okay, these are seven steps in algorithmic approach. Okay, first one we will see in detail each of them. If we see first one is understanding the problem. So we'll be writing algorithm to solve a problem. We have a problem here. The problem should be solved in an effective way by writing a algorithm. So first our step is to understand the problem. So we'll understand the problems very clearly and what data is given and what we are expecting. Okay, so we have a problem. So what are the inputs to this problem and what is the output of the problem should be known clearly. And we also know that the constraint, that is nothing but the boundaries. Okay, so the problem should be defined with a constraint or not to do a problem. Suppose we have example, if we say a is equal to 5 and b is equal to 0. Okay, if I want to add a plus b, it is okay, but if I want to divide a by b, it will become infinite. Okay, this is the constraint. That means b should not be equal to 0. So that is the constraints I need to specify for a problem. Okay, there are I given a simple example for a constraint. There are many constraints are there, so we need to know. So next one we have a analyze the problem. So here suppose we have a large problem or program we have. Okay, so the large problem should be divided into some convenient sub programs or sub problems. So we have a large problem. That large problem should be divided into some convenient small problem or program. So these problem or program should be solved here itself, and this will be combined together and will be getting a final solution for our main problem. So that is the meaning of analyzing the problem. So wherever it is possible, we will try to break down our main problem, that is a large problem or complex problem, into sub programs. And we will see the uh, so we will, whenever dividing, we try to forward the convenient relation to the sub problem or sub program, such that we can solve our sub program there itself. Okay, so this is the analyzing a problem. So this analysis or analyzation of problem can be easily understand with a diagrammatics. So in last videos we already seen a flow chart. The diagram will explain more than the content. Okay, so whenever you represent algorithm in the diagrammatic way, that will be calling as a flow chart. So analysis of the problem can be done very easily with the help of flow chart. Then third step, we have a algorithmic design. So we already seen. Uh, then we will be writing a algorithm. You can see it is the pseudo code. We said start, read number one, number two, and sum equal to number one plus number two, and we are displaying sum and we are ending. So these are cut and short words. That means there are straight words are there, very short forms are there. This type of algorithm we called as a pseudo code. We already seen in last session. Okay, when you written your algorithm in cut and short, that is very precise words. In a smaller words, we'll be calling as a pseudo code. So this is the pseudo code development. So we already have a flow chart in previous session. So here previous slide, sorry, in here we have a flow chart. So this flow chart should be converted into pseudo code in a convenient way. Okay, after design the algorithm, then we have a implementation of the algorithm. Here implementation of algorithm is simply we will try to write the code. So we'll be learning C language, so we'll try to write our code in a C. Okay, if you are learning Python, the algorithm should be converted into Python code, but here we will be converting into our C code. So that is the implementing the algorithm. Here we will try to focus on the syntax. Okay, whether we'll be properly using syntax to write this algorithm or not. So that we need to check. Next one we have fifth step is test and verify. So we will run after writing the code. Suppose we have a code. After writing the code, we will try to run that code as many as times with different inputs. Okay, so I said no in previous case. Suppose we have a age equal to 100 and b is equal to 0. We will try with these type of things, and we will try with different inputs, such that whether whatever code we written, whether it is running properly or not, that should be tested and verified. And we'll be checking any errors will be there. If there are any errors, we will try to rectify. Okay, already said no, division by 0 in arithmetic operation, that should be verified properly. Okay, so that is the fifth step of algorithmic approach. Next, when we have optimization. So we will try to optimize our program. Suppose if I see an example in a code, what I'm trying to do, in first step I will be defining integer a as a integer, b as a integer. In third step I will be writing sum, that is a plus b. But I want to optimize this one. How I can optimize? We will see. Now you can see. Now will be optimized. You can see I optimized. Instead of writing three lines, integer a, integer b, sum equal to a plus b. Now what I written? I written integer a comma semicolon. So that this is my first step. Second step I will be written sum equal to a plus b. So instead of writing three steps here, I converted into two steps. Okay. So this is called optimization. So wherever it is possible, I will optimize, I will reduce the number of lines, and I will try to optimize the memory allocation. Next one, we will have documentation. So we will be writing comments wherever it is required. Suppose I have, okay, what I'm trying to say, so I will be adding some comment here with a double slash. I will be saying, so it is a is a integer type. Okay, I will be saying A is a integer type, B is a integer type, and it is the sum of integer A plus B. So if I am writing a comment within the statement, that is also called as a documentation. And also I can write a comment or a note with a slash hashtag. I will write a multi-line here. Okay, I will have a multi-line comment. Then I will end with a hashtag and slash. So this is called documentation. Okay, this is also called multi-line commenting. This is called single line commenting. With a double slash, we'll be calling as a single line commenting. With a slash hashtag, and we will write a multi-line. Then we will end with a hashtag slash. So this is called multi-line commenting. These type of comment, if you add to our program, we'll be calling as a documentation. Okay. So you can see a simple example for understanding algorithm approach. So here our aim is to whether a given number is even or odd. So for that reason, what we are writing a algorithm. Algorithm is check whether given number is even or odd. So what we'll do, always will start. Okay, in algorithm, whatever you seen till now, algorithms is always have a start step. Then it reads a number. Okay. Then because I will be taking input as a number, and that should be, I will be saying whether it is a positive, so that is even or odd. So what I will do first, I will divide whatever number I taken by 2. If remainder, okay, is there, okay, I will be checking the remainder. If the remainder is 0, then it is even, otherwise it will become odd. Okay, then I will stop the program. Okay, I will definitely stop the program. So this is a simple algorithm. We already seen one algorithm at starting. So this is another algorithm to understand the algorithmic approach for solving any type of complex problem. It is a very simple problem, that is finding a even or odd. So so we seen I will be we will be seen algorithmic approach. There are 7 steps are there. First step, we have understanding the problem. Second one, analyze the problem. Third one, design the algorithm. Fourth one, we have a implement the algorithm. Fifth one, we have a test and verify. Sixth one, we have a optimize and refine. Seventh one, we have a document and maintain. So these are the 7 steps in the algorithmic approach for solving any large or complex problem. Okay, thank you.